Hello, everybody. Welcome to today's webinar, Clamp Seal Survive, MLS Gaskets, Torque Plates, and Surface Prep Masterclass with Ellering Klinger. My name is Amanda Goyette. I'm an admin assistant here with AERA, and I will be in the background helping with questions and moderating today's event with my colleague, Rob Monroe.
Hey, everyone. Yeah, Rob Monroe here. Got a real treat for you today. Florian is actually in and doing this webinar for us from Germany. So anytime we can have presenters at this kind of high level quality with these kind of presentations, technology has made this a real treat for us. So like I say, with Florian being over in Germany at his office over there, we're really, really glad to have him. It's a great treat for us. I look after membership and technical development at AERA. Just a quick note on what we have for regional conferences coming up. We have 3 planned for the year. April 17th, we're going to be out at Jasper Engines and Transmissions in Jasper, Indiana, and they're going to be touring Jasper. If you've never been there, this place is a must-see. If this is a regional that you definitely will want to attend, so that you can get on that tour and check that place out. And that'll be, like I say, April 17th. Then the next one we have is going to be June 12th. That's Rankin Technical College in St. Louis, Missouri. This college is very well equipped, and this will be another really good regional. Lots of really nice equipment at this particular school, and looking forward to that one coming up. And then June 27th, we'll be out in California, and that'll be Don Gross Sales, and looking forward to that one. So those are the 3 regionals that we've got coming up. You can see on the screen there on my slide. If you want any more information, you can go out to our website, and you'll be able to check out and register for those and get signed up. So look forward to seeing everybody there. There's always lots of good networking at these events. There's always a tour. We have lunch, so very, very well attended. And like I say, we have exhibitors there as well. So look forward to seeing everybody at those. All right, well, that's enough out of me. Like I say, we're in for a real treat today. Florian Kiziak from Ellering. This is, like I say, when we get a chance to get Florian on and what technology works properly, and we can get him on, especially with him being over in Germany, it's a real treat for us. He's covering some topics that we do get on the tech line a fair bit, and these are questions that Florian's going to be able to ask and answer and that kind of stuff for you today. So enough out of me, but I'll bring Florian on. So Florian, how are you doing today?
Hello, Rob. So I'm good today. Thank you for your question. I hope all of you are doing well. I'm pretty happy to present you our technical training today, and I'm very excited to share all the knowledge about all the gasket technology, what I prepared for you guys. All right, I would say don't waste the time. Just start with the first slide, and very important as always is like we need an agenda, we need what is coming up, what you can expect, and what I want to share with you. So of course I will keep you like a warm welcome. What I'm doing now, we taking about some 3 myths, so it means like let's see if they are true or not. Then we make a focus on the gaskets as itself, stopper coatings, all this kind of stuff. We make a failure analysis regarding gaskets, what's the reason for, and I give you some more insights. We speak about torque plates, what does it affect maybe a gasket or not. Let's see. And then in the last one, we are going for the service preparation to save the engines. So what it's do's and don'ts, something like this. And of course, if you have questions, then it's time to give you the right proper answer for it. Okay, jump into it. About me, I'm Florian Kiziak. I'm from Germany, as Rob was introduced you. I'm a technical trainer for more than 8 years. I have more or less like quite a good knowledge, let's say, about engine and sealing technology. I'm a more or less like global trainer worldwide. I'm also coming to the US, and I'm pretty looking forward to see you maybe on the World Pack or even like on the BIMmer show this year. So that's more or less like where I'm in the US. Otherwise, I'm here in Europe, quite far away from the US, but I'm traveling here and doing trainings also here in our regions and also on the rest of the world. Okay, but that's enough about me. Let's go into the topics. Why sealing fails? That's a good question, and maybe I can give you more information about this. In the end, there are more or less like 3 reasons for it. One of the reasons is incorrect clamp forces. So it means like if the clamp load is not the right one, that influences in a negative way our gasket. And if we have 40% clamp loss, that means also like we have not the right pressure to our gasket, to the functionality, and that could lead to some defects. That's the point. We have surface issues, which means like we don't take care about the right proper surface finishing. Means like some guys of you doing, I hope not, doing hand grinding because they want to save money or something like this. That creates maybe some micro grooves, and in the end, it happens for blow-by gases, especially if we speak about MLS gaskets. You will see later why. So it means like this is something what you should avoid. And of course, what is happening with any kind of gasket, we have a dynamic movement because we have a dynamic engine. Head to block is moving always, and in between is the underestimated part, what calls like a cylinder head gasket. And that means like they have to manage the main job to keep the contact surface to the head and even to the block. All right, let's go further. We have the 3 myths. So it means more torque seals better. Is it right? Is it true? We can discuss. MLS gasket can compensate bad surfaces. I don't know. And if it was machined flat, it must be sealed. So in the end, all of them are not true. So in the end, this is really like myth. So I cannot confirm it, and we will find it out together why it's not like this. In the end, modern MLS gaskets fail not because the gasket, and this is also always what we receive if we receive any gaskets for warranty or so something like this. I can tell you oftentimes and mainly the gasket is not the reason, it's something around. So it means somebody didn't take care about surface finishing, clamp load, and all of this kind of things. So this is like what we want to learn today, that you avoid this kind of situations. And before I go into the topics, I will show you what happens inside in the engine, because what we have nowadays and in modern engines more, we have these more movements. That means like head and block, they want to move to each other, and they have to move to each other, because what happens inside in an engine, it exists there an explosion, and the explosion wants to expand the parts from the top and even like to the bottom. So it means like we have fixed down our head to the block by the cylinder head bolts, and in between we have a gasket. And nowadays, the movements of the parts, especially head to block, are increased dramatically. The reason for it's quite simple, because the temperatures and even like the pressures inside in the engine increased dramatically, because nowadays you have more or less like on mostly of the engines, turbochargers, all of this kind of stuff, and that increasing more or less also even the temperature and the pressure inside in an engine block. And these kind of movements we have to handle. We have to more or less like control it with our gasket, that it really seals directly to the spot, even like to the liquid stuff like coolant and also to the oil, and of course the gases which is surrounding inside in our combustion area. So if we speak about cylinder head gaskets, there we have more or less like 3 different kind of technologies still in the market, still valid. Today we focus on one of them, and but I will also mention to you all 3 of them. So it means we have 3 of them. That means like we have a cylinder head gasket which is made out of soft material, like composite material. That's still available for older cars. Nowadays, modern engines, they have the MLS gasket, what we're calling a Metalloflex. That's a brand name from our side. It's a multi-layer steel gasket. How does it look? What is inside? What is happening there? I will show you later in the detail. And of course, we have metal elastomer gaskets, which are mainly used in heavy-duty applications like big, huge trucks, DD15s, and something like this, for example. These are used in those kind of engine types. In modern, more or less like passenger cars, we're using an MLS gasket today. That's it. As I written down here, we have there a thermal up to 300 degrees. We have minimal settling rates, and we have a compression compensation like 2 to 10 micrometers. What micrometers means, we will speak later. So it means like these are all 3 facts, what we have to keep an eye on it. But let's dive into the MLS gasket. How does it look like? What is inside in the gasket, step by step. So here's more or less like a cutted drawing of our MLS gasket. As I was mentioning, it's produced out of steel, and the steel is the main functionality nowadays of the material. So we have function layers, what it calls, on the top and on the bottom of the gasket. So it means like here on top, the golden stuff, and even like the lower stuff, we're calling this a function layer. Why there's a function, I will tell you later in the detail. In the middle, we have a carrier layer or a middle layer, let's say something like this. Could be also made out of a special steel, what we're calling a spring steel, or could be a cold rolled steel. So what is the benefit of the gaskets? We can, or we want to eliminate dynamics. So it means movements from the engine, from the head to the block. And to control these movements, we need a dynamic gasket, so a flexible one. Yeah. So how we can create a flexibility in a hard material, what is more or less like steel. The first thing what we need is like a steel which is flexible. So it means like we need a spring steel which is flexing back into the position as it was. But then it means like the main material is flexible, but we want to have defined spots which are flexible. And the defined spots, these are more or less like designed that we are punching into the metal a defined deformation. And the deformation is like a bead. So the bead is located, it exists two different kind of beads. One is like located around of the combustion chamber, what we're calling a full bead. I will tell you later how the full bead looks like in detail. And we have in more or less like in the back where the coolants and all the oil jackets are located, we have a half bead. So there's two types of different kind of variations of a bead. Why do we have two types of variations? Because the one is to seal against gases and the other one is to seal about liquids. About gases, you need more or less like a full bead because a gas is more or less like very thin and the viscosity of fluid is different, of oil, of water. So it means like a half bead is more or less like they're enough, let's say something like this. Also, what you will find on this kind of gasket, you will find there also a color. This is like a gray color next to the golden color. And the gray color is more or less like a coating. This is like a coating on the gasket, and this coating is necessary for the first start of an engine, because if you install a new gasket into the surface, then you don't want to have the situation that the liquids are going out because in the beginning the materials are cold. And for the first installation, we have this coating on top, and this coating is getting into more or less like the roughness of the surface and seals for the first start. Afterwards, it melts a little bit and keeps more or less like all the liquids for the first start inside. That's the main purpose of the coating. And of course, also eliminating the micro vibrations of the gasket, that it keeps in the spot where it belongs to. So it means like this is one of the main functions of it. So going more in detail about beads and how does it looks, and even like the material and everything what you will find. I have here a technical drawing. It's a real drawing out of our designs of the cylinder head gaskets. So what you will find here, this is the first one, is a half bead. A half bead is located, or it looks like that you're going from the lower part up, and that means like why we're calling this a half bead, because here on top of it we're going flat and not we're going back down like a sinus wave. It's going flat. It's exactly the opposite side. If you take a look on a full bead, it's going up and then it's going again down like a roller coaster. So that means like we created more or less a peak point and also two low points, and this is what we're calling a full bead. So what is now the benefit of the beads? Because if you see my hand, and my hand is now deformated like a full bead, we're going up, we have our peak point, and we're going down. We have here our surface of the cylinder head. So when we're getting in contact, we have now one defined sealing point, which is here on top. And now you have to imagine that this point is our sealing line, the completely deformation, the peak point. So we have one contact point to our surface. And if we get now pressure on the head to the surface, we can pressing down the material so it gets flat. But of course, if we release the pressure, it keeps the contact to the part and eliminates all the movements. And this is the benefit out of the shape of the full bead, and even the half bead is doing the same. And so we can eliminate movements. And the movements we can eliminate, how bigger the movements inside the engine, how more layers we add to a gasket. This is more or less like the secret behind. So it depends if your gasket has more or less like 3 layers, then you have on top a function layer, we have on bottom a function layer, in the center you have a center layer, which decides one time more or less like the thickness of a gasket. And there's also one additional function, what calls like a stopper. And later I will tell you what means like a stopper. This is also integrated in the cylinder head gasket. So the coating on top, this is like an FKM coating. So that is necessary because FKM is more or less like the right material on this. This is also what you can see here as a description. And in the middle, that like the middle layer has on both sides a nitrile rubber full screen coating. That means that's an overall coating. That's necessary to seal against the function layers on top. So it means like the dead surface and even like the dead surface that we have also in between the gasket a right proper sealing function. So if you check out here a little bit the values, like we have millimeters, sorry about this, but we are in the metric world. So it means like we have 0.0.15 is the coating thickness. So it's close to be nothing, let's say. And even like if we see, okay, what are the values, what we check about the design, the thickness of one layer is 0.25 millimeters, and even like the stopper, what we get mentioned later of it, it's 0.15. So we have really small tolerances where we creating gaskets which are more or less like precise for the sealing job. Because why I'm telling this so in detail, because later if we take a look about surface finishing, then you will understand that in the end the gasket is prepared to do a perfect job, but if you don't take care about a right prep of surface, then the best gasket will also fail. That's more or less like a quick, fast conclusion for you. So how the gasket looks like in an engine. So here's a nice model out of it. We have different kind of layers. The top layer is the function layer. Then we have in the middle, we have a middle layer. Then here around, you see this is like, a honeycomb stopper or something like this. I will explain to you exactly how it does it work and what is the main function out of it. But this is located in the center layer, and then it goes down, and then we have again on the bottom side, we have also again a function layer, which is located in the opposite side directly to the facing to the block. So the coating, I also told you, we have this micro roughness on top of a surface. So it means like this is always there, this is necessary. And we also want to grab into the surface. We want to seal against the micro roughness of the surface. And this is we doing by the coating. So quite simple. We put the coating on it. Also, in addition, what I forgot to mention, it's like you saw in the beginning, we have a golden color of the gasket. The spring steel, if it's raw, if it's untouched, if we put it into our machines, it's silver. But then it turns into the golden color. But for what kind of reason? Because we're doing to the material a heat treatment. And the heat treatment means like we're putting this into an oven for 20 minutes, heating up the material after we are punching out the design, the layout, and putting all the beads into it. And then it turns the color from silver into golden. That means like all the molecules inside in the material, it's releasing all the stress, and the strength is going back, and the flexibility to the material. That's a quite important step, what in the end is also giving our product a good quality. So, but coming back to the function, here's a good demonstration about what is a stopper doing and for what kind of reason do we have it. So here's more or less like some models. What if I'm activating it? You see on the left side, we allow a lot of movements because we have here no support element. And the support element, as you can see, is here a stopper. Because why do we need a support element? We not want to stress the material. We want to have a flexibility, but not allow the 100% of range of the stopper. Of the bead, sorry. So that means like we are locating next to our bead there a stopper functionality, and the stopper could be designed in different ways. Why it's designed in different ways? Because it exists different kind of engines. That's a quite simple answer, because we have gasoline, we have diesel engines, we have heavy duty applications, we have turbocharged engines, we have compressors, we have all the kind of variations of engines, and all of them needs a different kind of sealing or stopper technology. So here's more or less like a small overview about some of the stopper technologies what we have. We have they're also named as different kind of generations, because the first one what we were starting is like a fold over stopper. So it means like we take the center part and fold this over 180 degrees, make this flat to it. Nowadays we're cutting this in segments to release out of the stress of the borehole. in general, a stopper is located around of the combustion area. You will not find this in the back, more or less like next to a half bead. It's always located where we have our combustion gases, because this is where we have the highest movements overall. And here you can see we have different kind of generations. We have generation 1, generation 2, and generation 3. Generation 2 is a laser welder. That means like that process needs that we are taking out our first production, the center layer, and then we are doing a spot welding our laser, or more or less like the laser stopper into it. So it means like that's additional step for it. And then we have also coin stoppers, which are more or less like allowing us more possibilities. And one of them I will also show you very deep in detail. So here you also can see what are the strength and even like all the types of it. We have folded stopper, they have medium strength, we have medium flexibility. The benefit is a low cost product because you have only to fold it over, and it's more or less like designed to older engine. It doesn't mean that's a bad one. That's not like the case what I want to explain you, but nowadays generations going further and further. So the second one was the welded. That's have a high strength because it's a stiff material. We have low flexibility because it's stiff material. Of course, we have cost is high because it's additional production step what we need, and it's mainly used for diesel and heavy duty applications. Yeah. So nowadays you will find in modern engines a lot of coin stoppers. So that means like the serpentine stopper, what you can see here, or even like this honeycomb stopper, which have high strength, high flexibility, and the medium cost, because we can also produce this in one production step. And this is more or less like for modern gasoline engines and high performance engines used for. Yeah. All right. I think this is what we just explained in detail, so we can go over there. A nice animation, what you can see here now, it means like we have stoppers which are located now inside, and if we start the movement, then we have some spots where we need additional support elements. So what we don't want to have that our function layer is lifting up and is doing too much movements. This is something what we want to avoid, something what it's not nice to have, and therefore we have a solution for it. And the solution is quite simple, because here we need a support element. And this is now coming to a nice fact, because you can also test how good a gasket is working inside in an engine next to the surface finishing. Yeah. So you can do this kind of test with some Fuji paper. The Fuji paper is made by the company names like Fuji. And this is like a paper what you put in between of the gasket and the head and the block. And then you're tightening down your cylinder head to the block with the right torque use of the bolts, of course. And then it left more or less like inside into the paper some color print. Yeah. So here it's for this kind of situation, you find the red color. And this is a kind of a good test to see, okay, how good is the sealing line function? Because now we're coming to a point, and this is also what I want to mention. I was slowly explain you. We are sealing on one spot. So, and this is a big difference if we talk about the older gasket, the composite gaskets. This was an overall sealing functionality. Nowadays, we have a sealing line. And the sealing line means like we're sealing on one thin line around of the combustion area, or even like of our areas where we have the coolant and oil jackets, where we have the coating. That's the reason why you could see the red coating or even the gray coating, because this is defined only the sealing spots. So it means like that spots are very important. You have to keep an eye on it, that they are in perfect conditions, because they decide if the gasket works in a good way or even not. So, but the next challenge, and this is now coming to this slide, it's like we have more or less like clamp forces. And the clamp forces, the best what we would have is like as much as possible bolts around of the combustion area. Then we can tighten down the gasket against our head and block in an equal way. But yeah, the truth is we cannot decide it. We have to handle as it is. And this is like we have 4 head bolts mainly around of a combustion area. So that means like if we are tightening up our bolts in a good way, that means like we have high clamping forces next to the bolt. So it means like, as you can see here, on that kind of spot. So we have really good clamping forces, but there's also one point where we always like the farthest point between 2 bolts. That's like 12 o'clock, 3 o'clock, 6 o'clock, and even 9 o'clock. So in that kind of spots, we have less pressure because we have no influence of our clamp forces from the bolts. So on that spots, we want to have more or less like the same pressure as we have next to a bolt. So, but how can we decide it? How can we get it? And the best way, and this is like the solution for it, we put in our stopper. This is like what you're going to see here. We put there a topography inside. That means that, what means a topography? So the topography means like we are putting higher spots and lower spots into the inner layer, so in our stopper technology. In the end, in real life, a stopper looks like this. So we have high spots, peak points, and we have valleys. And the valleys will be like in the spots where we need it. So it means like 12, 3, and 6 o'clock and 9 o'clock. And the low spots, the valleys will be next to a bolt because there we have anyway enough pressure. So that means like we have not to increase it. So that's a quite big benefit what we have in the end to get a final result of our surface. As you can see here, we have a closed red line. That means like color intensity, thicker red, higher clamp load. That means like we want to have the clamp load everywhere in the right, same equal way. So this is like what you cannot see inside in the gasket, but we put it inside into it because we know how the engine works. So that means like coming back to our animation, we have now added to our animation a blue small topography. That means like in the spot where we have it, we have a support element, and this support element is essential and necessary. So that means like our expectation for a gasket is also the same lifetime as the first gasket was installed into an engine. So this is more or less like our way of thinking, our expectation to a gasket. And that's the reason why we're doing this research and development, even like in that kind of gaskets everywhere. So that's necessary. So here out of the real world, because the one looks like more like it's animation, but this is really like from a customer from the US. He did this on an LS engine, by the way, and make there also some testing. So he also compared a competitor head gasket, and as you can see, there was the imprints, the red color was not intensive enough because he had in general some issues about this kind of gaskets that they start with leaking. He had warranty claims, and then he was comparing our gaskets to the competitor ones, and in the end he did this with the same Fuji paper test, and the result is quite clear that also the gasket as itself decides how good will be the sealing function. Okay, so if you're interested in this Fuji paper stuff, you will find this also in the US market, but I will tell you it's very expensive if you want to do it. It's good, you can buy it, but the rolls are very expensive, by the way, but it's a nice test if it's necessary for you. So now we're coming to the point, we know now how the gaskets are working, but now we have to analyze, okay, what's the reason if we have a failure, how we can solve it, how we can analyze it. So in this case, I have now here 3 examples for you to reading the gasket, because in the end, that's very essential, very necessary that you have an eye on the gasket and understand what could be happening. Yeah. So that means like the first one, what we can see, there is a big defect on the sealing bead. This is like the bead is split in 2 pieces. And for what kind of reason? What happens to the gasket? In the end, what we're going to do is like we are putting the 2 layers together. We have here my hands, and we have our limiter. If I put this into the middle, we have a limiter where we are more or less allowing the maximum range of gasket which is going together. So we limited the way. And if this limit is not given in a proper way, even like to the up and even like to the low point, then it could also destroy a gasket. So it means like also even like the bead, the flexibility can break down. And if it breaks, there's a reason for it. And oftentimes there is more or less like the bolt forces was not in the right way. So it means like maybe somebody was not tightening the bolts in the right spot in the right way, or even the surface preparation was not given as it should be, or even like use the old bolts again. Something like this is more or less like a typical sign for more or less like this defect, as you can see here. This one is also like uncontrolled combustion. That is more or less like that we have blow-by gases. They are burning our gasket away, but also this kind of picture is also a classical sign for it, that we have more or less like a surface which is not milled or grinded in the right way, where we have still grooves, where we allow more or less like for new gasket to have blow-by gases. And this is could also lead more or less like to a defect like this. Or even like if we have block or head movements which are eliminate more or less like our gasket, more or less like coating on top, that could be also leading to some more or less like defects on the gasket as itself. Here we have some spots which are blank, but blank spots are giving us as a sign that we had a good more or less like contact from surface to the gasket, because they was working to each other. But if it was scraped away, then it's also a sign of that the gasket allows to have a movement. And even like here, this rainbow colors is a clear sign for overheating situation on the gasket, that maybe we had also blow-by gases into the water channel, oil channel, depending, and it's heating up and destroying more or less like the gasket as itself. The other point is that we had more or less like the clamp forces was not correct in the way as it should be. So it means also the gasket was over tightened. It could be also possible more or less like, or even like it was too less clamp forces, and then even like an MLS gasket can also have a defect, as you can see here, and it was blown away. Coming back to our example with the MLS gasket, which has a broken down bead. This is now a detailed view, as you can see here. As I said, the degrees of clamp forces, they released by themselves. It was in general incorrect. Nobody was reading more or less the paper in the beginning. We had massive movements from the parts, and even it could be also come from uncontrolled or incorrect combustion inside in the engine. The other example, what we've seen in the beginning, it was like this blow-by gases was more or less like destroying the gasket as itself. Here you could see we have a shared bead. This is also something in modern engines, that you have not separated beads, because as you can see here on this layout design of the cylinder head gasket, we have here a bead which is more or less like alone, and then it's merging together with the opposite side, and then we have one completely shared bead, and this bead is working oftentimes to aluminum parts, and aluminum parts against steel left some grooves, and these grooves are very important to keep an eye on it, especially if you're changing parts. Then you have to measure it with a straight edge, that you are in a good situation, that you're checking here is no blow-by gases they are blowing by. If you don't take care about it, you put a new gasket in it, of course the gasket get damaged maybe very soon. But the additional negative effect could be like that the head and even like the block has also a defect situation for it. All right. The last one is like if you have any kind of defect cylinders, liners, more or less, like you can also fix them. You have to check them in the beginning before you're installing a new head gasket. You can there also some welding, which is also possible, of course, but here's also a good knowledge necessary that you don't stress the material in general. Nowadays, it is possible to do laser welding, which is not influencing the material with hot temperature. It's not stressing the material in general. And so you can nowadays easy fix also more or less like aluminum parts in a good way. This laser welding is quite a good solution for it, what I can highly recommend. And you can really fix there a lot of imperfections, heads, blocks. But this is also very important before you install something. You have to identify with your eye and even like with your finger if all the kind of surfaces are in good conditions. One major thing is also like the heads. Many times they have also kind of a distortion because we have a lot of temperature influence, especially in aluminum parts. They could be bended. The one thing is like that we have a bended head, what you can check with a straight edge. But the other side is also oftentimes some modern engine has also on top of the heads the camshafts inside, and if the camshaft cannot rotate anymore, then you have also a kind of a problem with the head. So this is also essential that you check the heads before you install something, and if it's really bended, like if you see here distortion, then you have to bring it to a machine shop that they take care about it. Yeah, that's very important. So if we speak about torque plates, thermal overload, and all these kind of things. Now we're coming to the point to our torque plates. So is it necessary to take a torque plate to unblock? Even like if we talk about cylinder head gaskets and surfaces. Of course, if you hone a block, it's not maybe to all of them necessary, but it's helpful if you have torque plates on top. For what kind of reason? Because in the end, what you want to create, you want to hone a straight way into the liner. You want to hone it in the right way. And you have to imagine that you have to rebuild or restore more or less like a situation that the head is more or less like on the block, and then you're doing the honing to the block. What means like this to the surface? If you see, if we do not hone engines, but we must understand how bore distortion affects sealing contacts. So it means we could be also affect that our surface is not flat. And if it's not flat, then it affects also our gasket. But in the end, it affects more if you hone your engine blocks without these torque plates, that it's no more round. Because in the beginning, if you're measuring a cylinder liner, and even like the temperature is also a big effect, then it's not round. Then this is especially what you see here. And what you create if you torque you down the plate, the torque plate to the engine block, and then you go inside and hone more or less like the engine block in the right way, then you rebuild the situation as the head will be mounted more or less like to the block. And it is like in the end how the engine works in the normal operation time. All right, if we install our gasket, then if I was marking it on top, surface finish is #1 route for causing sealing failures on alloy engines. So that means like this kind of information you will find also on our tightening instruction inside in the cylinder head packing. But these steps are very essential and very necessary to know. So the first thing is like if you remove anything from a surface, a rest of old material of a cylinder head gasket, doesn't matter what it is, don't use a metal scraper, because especially in aluminium alloy engines, they are very soft. You can destroy the surface by scratching the surface, and any kind of scratch, especially where we have our sealing function, our liner sealing function, our line sealing function. This means you have to avoid any scratches. Of course, we have to remove any liquids from the surface. That's also very necessary. So cleaning the environment, no coolant, no oil. We protect the cylinder liners, the cylinder bores by a towel that no dirt is falling inside, because the next step will be like we're blowing out our threads, our bolt holes with compressed air, because we can not release somewhere else the oil or any kind of liquids. So we have to flush it with the air out of the engine block. That's very essential and very necessary. So the next step will be like we checking the flatness of the surface, and we checking this with a straight edge. This is quite essential, and there we have two values what you have to keep in mind. The one value is like in the long attitude, we have 0.05. So it means like 5 of 100 that we taking this care. And in the short way, so in the width, we have 0.03, like 3 of 100 millimeters as a kind of a tolerance what the cylinder head gasket can handle. So if we see now roughnesses, and this is like giving you some small insights about roughness, then we have here a comparison in our chart from the soft composite material into a metal layer steel gasket. And here we're taking care about two values. And one of the values, the RZ, this is more or less like an average of a roughness, what we're gonna measure inside on the surface. And we have an Rmax. So doesn't matter what the values means, like the micrometers or even micro inches, what you can see here. What we can easily analyze is like that we have a difference from the soft material to the metal layer steel gasket. And if the value getting smaller, that means like the surface finish getting smoother. So it means like If it's roughness you can see, you can feel, and this is also one thing what I want to tell you, that you can use your eye and even like your finger to check surfaces. I will also show you some examples where it exists professional tools, but the first thing what you can do is like check surfaces by your eye, even like by your finger. If you see there's a deep scratch and it's exactly on a ceiling line, and the ceiling line is very easy to identify by the gasket, by the coating. If you see on the coating spot where the gasket belongs to the surface, there you have a scratch. Don't install the gasket. Go to a machine shop and take care that the machine shop is overhauling your surface. This is the first essential thing. Yeah. So, but if we compare now the values, then we speak about micrometers, but you have to understand what means micrometers. And micrometers, giving you some examples, we can speak about different kind of things inside in our world. And 1 micrometer means like, if we're going now, a virus is very less. We have a bacteria that's 1 micrometer, so nobody can see a bacteria. So that's the point. A spider web is more or less like 2 to 3. A blood cell is 5 to 10. And now is something what we can really catch up. It's a single human hair. There's a single human hair is 40 to 20 micrometers thickness. This is something what we can feel if we still have hair. So if we are lucky ones, then we still have the hairs on top. And this is like the thickness of a hair is like something what we're speaking about. Yeah. And so that means like if we have roughnesses like the thickness of a hair, then we are close to the borderline that maybe it's too rough for a metal layer steel gasket. Yeah. This is an essential point. So we can have 3 different kind of surfaces what we prepare. The one is like, as I said, we're using a grinding paper by ourselves and we are preparing our surface in a straight way. We are pushing sometimes harder and then we're creating deeper grooves. We have an undefined surface. On the opposite side, we are eliminate all the peak points. That means like we are polishing our surface, but maybe we get not into the lower spots, then we are lapping something. This is what we're calling a lapped surface. And the best surface overall will be a milled or grind surface. This is like a repeating shape, which is coming up by our cutting device, which are going over the surface. And this is like what an MLS gasket loves to have, because these are the gasket surfaces which they can handle it. There is repeating always peaks and valleys in a defined shape. And that means like a metal layer steel gasket wants to have the center one. And there we can more or less like be on the safe side that we also fulfill the expectations of the lifetime of a gasket as it was installed before. I will not say all the others will not work out, but you cannot expect maybe the lifetime as we expect for a gasket, that it's really like the same lifetime as from the beginning, the first installation of a new engine. So give you some real figures out of the real world, because these are schematics. This is something what you can measure. This is a very smooth surface. This is an example out of an engine block. If you see, and this is now coming back to see and feel, you can see here a difference, because as you can see, it's a very, very, very smooth surface. You can even not feel any kind of roughness. It could be close to be polished. Here the diagram is very close to each other, the peaks, and if we see the roughness value R set and R max is 2.3 and 2.5, there's close to be no roughness. Yeah, this is like a surface which is quite good, but maybe too smooth. Now it's a question, maybe does exist a too smooth surface? No, it doesn't exist a too smooth surface. It only exists a too rough surface. Yeah, that's a quite essential point what I want to mention to you. In real world, this is like yeah, the readout of the MAR instrument. This is like a small type, yeah, a small pin which is going, a stylus. Now I found the word, the stylus, which is checking the surface, and it's going from point A to point B on 1.5 centimeters and giving us a result here, as you can see in 5 segments, how the roughness looks like. So the next example would be like a roughness which is more or less like quite okay. And here you can see by the picture, you can really see the lines. And some of you maybe thinks, oh, that's too rough. But in the end, if we measure it, it's 7.6, 8.8. So it's still in the middle range where the gasket can work, because the high points, or more or less like the borderlines, is like for our set, we are speaking about 11, and our max could be up to 15. So it means could be double as rough as you can see here on the picture. So that means like really this is like a surface where the MLS gasket can work. And keep in mind, these should be everywhere around all of the surface. So that means also if you pick up your parts from the engine shop, which are to care about it, then handle the parts like raw eggs, because you don't want to have a scratch on it, not by handling it back into your trunk in your car. So really take care about that this surface is in perfect condition, what you receive from your engine rebuilder shop, and then put it very, very in a safe way back to the engine, that you are in the safe way. You have no defects on the surface, but it's created in a good way. This is like a real readout of the MAR tester. So you can really see the peak points, the valleys, peak points, valleys. I explain always the best is like if you have your bread knife at home, and the bread knife is always like if you turn the bread knife up, then you have the same shape, the wave shape, and this is like what a gasket likes to have. This is really what they like to handle. So the last example here we have more or less like a prepared surface by more or less like hand finishing, let's say, with the grinding paper and so on. So it's undefined. It's not really crazy, because this is also what you can create, because maybe you also see this some viral videos where some guys putting on a grinding paper, a flat grinding paper on maybe a glass or something on the desk, and putting there a head on it, and then sliding it up and down, up and down. And of course, he's also eliminating any kind of grooves, movements, and so on. But he's creating more or less like an undefined surface. It also depends what kind of grit of grinding paper do he use. Do he use an 80 grit, or do he use a 250 or 500? If it's getting smoother, also the surface finish getting smoother. So I would not say it doesn't work, but it's not the right expectation for a surface finish what we think about it. Yeah. So here you can see we have undefined high spot, undefined low spots, and the biggest problem overall, it is for a gasket in general, the low spots. So it means like these spots are very, very critical, because we have rough material. We cannot have something to fill it up. So in this case, this is something what you should avoid. Recommendations, here you see something what it's not good to do, even like this roll lock disc, something like this, to remove marks and all this kind of stuff. Don't use it. Don't use abrasive discs that or even metal scrapers to the surface. Everything is possible what you will find as practice out in the market, but I can really recommend go and machine it. Take care that it's in the values, and use your eyes in the way that it is more or less like in good conditions as it should be. So last step from my side, assembling, because now we have everything prepared. We understood what it means like inside the engine, how we have to take care. First thing, and this is the most asked question overall, can I add something on the cylinder head gasket? Couple spray, whatever you like to add. Couple spray, read again the can. Is it written down on a couple spray can? Use it for MLS gasket or cylinder head gasket, you will not find it. I'm pretty sure. So with our ones, with our gaskets from A-Ring, you don't need a copper spray. In some points, it's maybe possible you need a drop of RTV. That is essential on some points where we have more or less like timing covers from the front. We have T-shapes. There's necessary to add one drop of silicone, but you need nothing to covering up the head gasket on top or even like on the bottom. That's not necessary. If you install the gasket, check that it's mounted in the right direction. Top marking is more or less like written down on the gasket, so it should be looking to you, not take the top and flip it down. That's not the right way. Then be careful with the head, sharp edges, that you don't destroy your surface, don't destroy the gasket. And of course, now comes very important point, use new cylinder head bolts, because we also learned today the clamping forces are essential. They are necessary that we are keeping them in the right spot. And that's the reason why you have to use new head bolts. And only with the new stretch bolts, you can create the right pressure from the head to the block. That's also the next step. Follow the tightening instruction. The sequences start in the middle, go to the outside. if it's necessary, if it's written down, start with number 1, end with number 10, for example, and then go with the right torque cue, and then go with a proper rotating angle. Folks, this is more or less like everything what I want to share with you. Some last slides, and these are maybe some helpful things because we love to share knowledge, as you see here. We want to invite you to our social media. You see here 2 QR codes. The one QR code is leading you to our playlist on YouTube. There are some shorts. There are some helpful knowledge. We're calling this the Tech Talk. Yeah, this is like a airing garage Tech Talk. Also, what you see here, this is like a new platform what we launched, where we're gonna show and share in this kind of case helpful knowledge. Shorts, 1 minute, not more. You can see. I think you love it. Even the same you will also find on our Instagram. So you will find their airing official Instagram, and there we're also sharing in the future more shorts, more helpful insights. So you're more than invited to find us on our social media platforms. And now we are on the time, and in the time, I hope so, for questions. So if you have questions, now it's time for the questions.
Hi, Florian. Yes, no, we do have some questions, and that was an excellent presentation. Really enjoyed your slides, Florian, are high quality. Like they're very, very good slides. It's almost like we were watching video. So whoever does your slides and takes your pictures and everything, they do a great job because those are really high quality. So that was an excellent presentation.
I would do it by myself, so.
Right? Yeah. Couple questions for you. You were talking about surface finish, and there were some specifications there for surface finish. Do you know where we can find out like the surface finish or what it should be for some of your head gaskets? Like, does it come with the instructions with the gasket set, or is there a website we go to find out what the surface finish should be?
The chart, what you could see in one of the slides where we've written down, okay, what is the values? This is what you find on all tightening instructions, which is coming together with a cylinder head gasket. So if you're buying a cylinder head gasket from us, there's a tightening instruction. If you turn it around, there's this chart. You will find it there again.
Okay, good to know, because that is a question that we get on the tech line all the time is, you know, what should the surface finish be, or what's the parameters for the surface finish? Yeah. So that's excellent. Another question for you is, if, for example, you've got an LS engine with a bore, which is 4.030, and you're using a head gasket, let's say from a different application that where the chamber size is bigger, where it's 4.130, what do you use to determine the correct gasket bore?
That's really a good question. Thank you for this. And it's a challenging question, but in the end, what you have to focus on it's always like, what is the biggest size? And what is the biggest size means like the head decides he's bigger as the block. And that means also it leads to us that we have to choose this kind of size as more or less like a golden, or more or less like a figure what we have to find the right size of gasket. So it means like this is giving us more or less like the right direction where we have to go. So the 4.130 is more or less like our value, what we have to take care that the bore size is matching to this kind of value. So it means like in this case, you have really to find the gasket which has the right bore size for the head, because this is also influencing a lot of the function.
Okay, no, that's good to know. Okay, so another question for you. What would you recommend to prep the gasket surface? Like, is there anything that you'd recommend to kind of get it ready for your gasket?
In the end, so the professional way will be going to an engine rebuilder shop, and they take care about milling or grinding the surface, of course. As I was mentioning to you, oftentimes guys wants to do something better. And if you measure also even like used surfaces, and they have really no more or less like distortion or any kind of imprints or grooves, then it sounds crazy, but leave it as it is. This is more or less like one thing. Oftentimes you do something more worse instead of doing something better if you're not doing in a professional way, let's say. I recommend always going to the engine rebuilder shop and doing also, and this is also something what you have, I hope so, I told you the right way of information, because both surfaces are very important. That means like head and block. because the gasket has on both sides the same functionality. So that means like the recommendation, or yeah, more or less like the requirements of the surface finish must be for the head and even for the block the same. You cannot say I'm only going with my head to the engine rebuilder and they take care of what mainly the guy's doing. I know it, and leave the block as it is. Also, it's a big influence about what kind of material do we speak about. Is this a cast iron block? Of course, the cast iron is quite hard. There's more or less like less influence about an MLS gasket. But if we speak about an aluminium block, this is a soft material against steel. So there could be happening that you have grooves. So my personal, let's say, yeah, recommendation is of course going to an engine builder shop instead of using any kind of grinding paper and so on. So this is really not the professional way. Yeah, I will not say it doesn't work, but it's not a professional way.
Thank you for attending. We know you guys are busy and we appreciate you taking time out of your day to attend these. If you need to reach anyone at the AERA team, you can reach us at 815-526-7600, or you can always shoot an email to myself or Rob. Our email addresses are listed there. Also, make sure to go out and follow us on social media. We're on Facebook, X, Instagram. We talked about our YouTube page, and we're also on LinkedIn. So go out there and make sure you follow us so that you don't miss out on any upcoming events and content from AERA. And with that, I will let you all go, and I hope you have a great rest of your day.